Hey guys, welcome back to another video, and as you can tell by the title, today we're going to learn how to use trig identities. And so in this video I'm going to show you guys what the properties are of basic trig identities and how to use those properties to solve for an identity. So the first trig identity we're going to be talking about is the reciprocal identity, which states that sine of theta times cosecant of theta equals 1, cosine of theta times secant of theta equals 1, and then tangent of theta times cotangent of theta equals 1. And since it's the reciprocal identity, this means that we can also have sine equals 1 divided by cosecant, cosine equals 1 divided by secant, and tangent equals 1 divided by cotangent. And we could also have cosecant equals 1 divided by sine, secant equals 1 divided by cosine, and cotangent equals 1 divided by tangent. So second we have the quotient identities, which states that tangent of theta equals sine of theta over cosine of theta. Then we have cotangent of theta equals cosine of theta over sine of theta. Then on this side, we have the tangent of theta equals secant of theta over cosecant of theta. And then we have cotangent of theta equals cosecant of theta over secant of theta. And lastly, we have the Pythagorean identities. So in this list, we see that sine squared of theta plus cosine squared of theta equals 1. 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta equals cosecant squared of theta. So there are a lot of other identities, but for now in this video, for the examples we're going to use, we're going to be using these identities I listed, the reciprocal, quotient, and Pythagorean identities. So for our first example, we have cosine squared of theta times cosecant of theta times secant of theta, and we want to transform that to cotangent of theta. Now, for the first step, we should list some possibilities of what cotangent can be transformed into. From the list that we just learned about, we have cotangent of theta could be transformed into 1 over tangent of theta, or cosecant of theta over secant of theta, or cosine of theta over sine of theta. For our first step, for the left side, we're going to use a reciprocal identity to transform cosecant of theta over to 1 over sine of theta. And then parentheses, because we're going to multiply it by secant of theta, which is going to be transformed into 1 over cosine of theta. And then now we drop down the cosine squared of theta. Next, we want to multiply the cosine squared of theta by the 1 over cosine of theta, and then you would get cosine squared of theta over cosine of theta. And then drop the 1 over sine of theta. Okay, so now we cancel out the cosine theta on the bottom because this is the squared on top, so you just take out 1 and you would end up with cosine of theta times 1 over sine of theta, and then do basic algebra, and then you end up with cosine of theta over cosine of theta over sine of theta, which is your final answer because this equals that, which equals the cotangent of theta. So our last example, we have 1 plus tan of theta, all this is squared, and we want to transform it to secant squared of theta minus 2 tan of theta. So what we want to do first is do the multiplying of this out. So we would end up with 1 minus 2 tan of theta plus tan squared of theta. Right off the bat, we could tell that there's a Pythagorean identity in this equation or problem. And then now, so we have 1 plus tan squared of theta, which equals secant squared of theta when you're using the Pythagorean identity. And then we just drop down the minus 2 tan of theta. And then we have a final answer right here.